Hello class! Again, I'm Mrs. De Pedro and I am here to discuss with you hypothesis testing. Because of the emerging crisis we have in the country, I decided to make this video so that you can understand hypothesis testing more, the basics of hypothesis testing. I hope that you get to understand this one. So if you get to understand this, for sure, the next topics will be a lot easier for you. So I hope that you spend time watching this video. And if you have questions, I'm very open to answering your questions through our official Benilde email account. So you can always contact me and send me messages or send messages to my Benilde email account at emervic.depedro@benilde.edu.ph. So to start the discussion of hypothesis testing, let me bring you to our PowerPoint presentation. Ayan. So remember last time, we have the different tests on significance of difference between mean. So we have touched z-test, which is used when sigma is known, and t-test, which is used when sigma is unknown. But in our future discussion, you will also encounter f-test, or likewise known as ANOVA, which is to compare 3 or more means or 3 or more groups. So to start with the hypothesis testing, I would like you to recall the different z tests. So last time we have z test for one sample mean, tama? So that is comparing the hypothesis or the population mean to the sample mean. And again, you can only use this formula if the population standard deviation is known. So we can compute for z if we subtract our population mean from the sample mean, and then we'll multiply the difference by the square root of the sample size and divide that by the sigma. So note that the following stands for the sample mean, x bar, and then mu for the population mean, and then n for the sample size, and sigma for the population standard deviation. So you're going to use this if you are comparing only one mean or one group to the population mean. If we have one sample z-test, we also have two sample z-test. So in this way, we compare two sample means. So the first sample mean versus the second sample mean. So notice that in computing for the z, we get the difference between the sample means and then divide the difference by, again, sigma must be given, multiplied by square root of 1 over the first sample size plus 1 over the second sample size. And again, you may look at this legend for reference. This is now the highlight of our discussion. So I'm sure you had a very hard time understanding this during your senior high school statistics and probability. I will be discussing two approaches in hypothesis testing. So they are critical value approach and p-value approach. For both, you have to follow 5 steps. In critical value approach, we compare the computed to the critical. So that's the basic, the basic thing we do under critical value. Unlike in p-value, we only need the alpha or the level of significance and the p-value. P-value may be obtained or may be generated using the computer softwares we have right now, which are accessible, no, for your generation. But you may also get the p-value yourself, no. For critical value approach, again, you have to formulate the null and alternative hypothesis, which I already taught you, no, in the past weeks. You have to do the same thing in the p-value approach. So in both, you have to formulate null and alternative hypothesis. And then on the second step, for both approaches, you have to select the most appropriate level of significance. So I already taught you how to decide over alpha. If it's not given in the problem, then you have to use 0.05. What's the difference between the two approaches when it comes to the second step? So in the critical value approach, you have to use the critical value, which you may see again from our table of values. So do you remember? Ayan, the standard normal Z distribution wherein you have to find the critical value approach. And we also had table for this one. So when we proceed to hypothesis testing, you will remember, no, how critical values are obtained. And then for the p-value, you have to p-value approach, you have to write the p-value, which can be obtained from the computer software or application that you use in hypothesis testing. And then for both approaches, you will have to do the same steps for 3, 4, and 5. Write the decision rule in number 3. So you state no when to reject the null hypothesis. And then for number 4, you have to make decision. And decision is based on your computation for critical value approach. While in a p-value approach, it is based on the p-value and alpha you had in number 3. And then conclusion for both will be based on your decision for number 4. From number 4. So I will just have to spell out the steps. We begin with the critical value approach. So the first one is to formulate HO and HA. Set the level of significance alpha. Usually it's given in the problem. And then find the critical value. Do you remember this table? So I've shown you this in our last discussion. And then for the third step, you formulate the decision rule. So when to reject HO, and then you make your decision, and then you formulate your conclusion. Now for you to understand this fully, we have to take an example. So look at the example. The average score in the entrance examination in mathematics at the Big Time University is 80 with a standard deviation of 10. A random sample of 40 students was taken from this year's examinees and it was found to have a mean score of 84. Is there a significant difference between the known or the hypothesized or the population mean and the sample mean? Test at alpha, which is 0.05. So if you may notice, there are important values that we have in this problem. So what are the values that you see in our problem? So if you may notice, I'll be writing on the right side. So we have there 80. What else? 10, 40, 84, and obviously alpha is 0.05. So what then is our 80? What is 80 in this problem? Sabi, it's the average score in the entrance examination. So we consider this as our mu. How about 10? So this is our population standard deviation. As a random sample of 40 students, so how do we consider 40? So that is our N, or the sample size. While 84 is obviously the mean of the sample. So we make use of, ayan, X bar for that one. So is that clear? Now, let me ask you, how many samples do you see in this problem? So that's my baby that you could hear on the background. How many samples? There is only one sample or one group that we can see in our problem. So what type of test are we going to use? Z-test, T-test, or F-test? Since sigma is given, then we have to use a one sample Z-test. Kasi we just have one group. Do you see that? Ayan, so this is what we have, no? Mu is 80, sigma is 10, n is 40, x bar is 84, alpha is 0.05, and we have to use one sample z-test. Now, I would like you to recall the steps on hypothesis testing. So, the first step, if you may recall, is to formulate HO and HA. So, what is the original claim in the problem? So, notice that we just have this question: is there a significant difference between the known mean and the sample mean? So, is there a claim that the mean of today's batch is greater than the mean of the past batches of examinees? So, none. So, for our null hypothesis, we just say there is no significant difference between the hypothesis and the sample means. So in symbols, we write that as mu is equal to 80. So if this is not true, what then is true? Then you will have to formulate our HA or H of 1, or what we call the alternative hypothesis. There is a significant difference between the hypothesis and the sample means. So that is in symbols, we write mu is not equal to 80. Okay, I hope that one is clear. So for the second step, you have to set the level of significance. Usually, ayan, it is given in the problem. Find the critical value. So what alpha do we have in the problem? It's already given, so alpha is 0.05, as you may see. So we just copy that. Okay. Again, in the second step, you have to find the critical value. So what do we have to recall for this one? You have to recall this table. Ayan. So from H of A, we have a two-tailed test since HA uses not equal to symbol. Since we have a two-tailed test, then you have to look at two-tailed. What is our level of significance? 0.05. So, 0.05, a two-tailed test. Therefore, do you see the laser? Ayan. So, it points to positive or negative 1.96. So, our critical value, actually, our critical values are positive and negative 1.96. I hope that one is clear too. So let's have the third step. For the third step, so I just made steps 1 and 2 smaller. For step 3, you have to formulate a decision rule. Again, this will tell you when to reject the null hypothesis. So what do you have to remember in stating the decision rule. So I would like you to recall this illustration. Do you recall this one? Since we have a two-tailed test, our HA uses not equal to, then the rejection region is composed of, ayan, two regions. So dividing alpha into 2. So again, recall that we reject the null hypothesis if we have, ayan, the values from this point to this point and the values from this point to this point. Recall that our critical values are positive 1.96 and the other one is negative 1.96. So when do we reject our HO? So if we get to a value greater than or equal to 1.96. So if we get values from 1.96 and more than that, we reject the null. If we also have values less than negative 1.96 or equal to negative 1.96, then we have to reject the null hypothesis. So in words, we write that as reject HO if the computed value is greater than or equal to the positive critical value. Or you may simply write that as reject HO if the computed value is greater than or equal to positive 1.96. Or, so you have to include that statement. Or if the computed value is less than or equal to the negative critical value. So you may simply write if computed value is less than or equal to negative 1.96. So otherwise, if that is not the case, then you accept HO or you say do not reject HO. So is that clear? I hope that is clear. So I have to erase this one so that we can continue. So again, I have to make the font smaller so that we can proceed to the fourth step. So for the fourth step, make your decision. So we can only make a decision if we compute for the Z. Remember the formula? I have to teach you how this one is done manually so that if computer softwares are not available, you can still use the manual thing or the formula itself. So what formula are we going to use? Remember the formula we have a while ago. So that is Z is equal to X bar minus the mu multiplied by square root of N divided by the population SD. So all you have to do is to substitute the values that you see on the right. So what is our X bar? So that is 84 minus 80 and our sample size is 40 divided by our sigma 10. So if you are holding your calculators right now, you will get 2.53. Question: how do you compare 2.53 to our critical value? Since it is positive, then you have to compare it to our positive critical value. And our positive critical value is 1.96. So how do you compare 2.53 to 1.96? That is greater than. So if our computed value is greater than 1.96, what must be your decision? Very good. You reject HO. Since our computed value is 2.53 greater than 1.96. Sorry, that's my baby. So, since we reject HO, what then is true? What then is true? Our HA. So, we may conclude that there is a significant difference between the hypothesis and the sample means. So, in the context of the problem, you may still interpret that as there is a significant difference between the average scores in the entrance exam in mathematics of this year and the previous year's examinees of big time university. So, I hope that one is clear. Now, I can give you another example, but this one is somewhat similar to our first example. But if you may notice, there is already a claim in this problem. So look at the last part. Does this indicate that this year's batch is better in mathematics than the previous batches? So how do you find it different from the previous example? Notice that this time we already have a claim that one is greater than the other. So in that case, there would be changes in our HO and HA. So for our HA, this year's batch is better than the previous batch. Why did I start with HA? Because that is the claim in our problem. So that means our mean is greater than 80. So we're testing whether it is really greater than our parameter 80. So what then is the opposite of this one? When mu is less than or equal to 80, or in words, this year's batch is not better than the previous batches. So how will the next steps be different from the previous examples or from the steps in the previous example? In step 2, again, our alpha is 0.05, that's given in the problem. But since we are using a one-tailed test or a two-tailed test, so this time we're using a one-tailed test, in particular to the right. So if you recall the table again, for a one-tailed test whose alpha is 0.05, then you have to use one of this. Since we're using a one-tailed test to the right, then we have to choose the positive critical value, 1.645. So for step 3, our decision rule will be shorter this time. Why? Because we just have one tail. So we reject HO once our computed value is greater than or equal to the positive critical value, in this case 1.645. So if that's not the case, then we have to accept HO. And for the fourth step, again, you will compute for the same value, 2.53, because you are going to use the same formula. So if 2.53 is greater than 1.96, then it would be greater than 1.645. So we again reject the null hypothesis. So if we reject the null hypothesis, then what then is true? HA. So this year's batch is better than the previous batches. Okay, so I hope that this video helps you now to understand how the basics of hypothesis testing works. But as I've said, class, we are not going to use those formulas, and even in real life, you will be using the p-value. But why did I discuss that? Because you will get to understand p-value if you understood critical value approach. So for the p-value approach, I would like to introduce the pH stat. So I have introduced this to you in our I think meetings during the first week. Ayan, so this is one of the softwares that we are going to use. This is for free. You can always download its installer from the web or from the internet. However, it would be a problem if you're using Mac, because this doesn't work in your converter. Ayan, Office converter. So once you have installed this on your units, you will see this icon. So all you have to do is to double click, and ayan, a window will appear. So you have to go to add-ins, and then you will see pH stat. So what you have to do is to click on the scroll down button there, and then you have to choose among the tests. So in this problem, by the way, we are using the same problem, the first problem that I have presented to you. So as I've said, we will be using a one sample test, z-test. Ayan. So what we have to press on pH stat. So you have to use a one sample z-test. And then you have their options of using z-test for the mean, sigma known, t-test for the mean, sigma known, chi-square test for the variance, and z-test for the proportion. So what we have to use? Z-test for the mean, sigma known. So you click on that, and then again you will be shown a dialog box wherein you have to fill out. So for the null hypothesis, what are we going to type in for the null hypothesis? So it must be 80, the population mean. And then for the level of significance, obviously is alpha 0.05. Population standard deviation is sigma 10. And then for the sample statistics known, sample size is 40 and sample mean is 84. And we are using a two-tailed test in our first example. So if you do that, it looks like this one. So we have 80.05, 10, 40, 84. And you tick on two-tailed test. And you can always write a title, no, for the output. And you click on cancel. Hindi, okay. Click on okay. So once you click that, you will have the result. So even the decision is already shown by pH stat. So if you may recall, these are the given conditions. And what do you remember about z-test statistic? So it is the computed z-value. Remember 2.53? We have computed a while ago. So that is what we call the z-computed value. So in a pH stat, that is z-test statistic. And what do you remember about these two? They are the lower critical and the upper critical. Do you remember negative and positive 1.96? Okay. And then, this is the most important part of using a pH stat, the generated p-value. So, if you may notice, we have to copy p-value on this side. P-value is equal to 0.011412036. Ayan. Pareho naman. Okay, so p-value is what we're going to use in our next discussion. Now, if you wonder how this one is obtained, I can also teach you from this video. So, if you may recall, class, what was our computed value a while ago? That is 2.53. 2.53. So, this is within the rejection region whose critical value is 1.96. Now, from 2.53, I would like you to recall how the area is obtained from 2.53 to the right is obtained. So do you remember our lesson on areas under the normal curve? So from 2.53 to the right of 2.53, we have to find the area. Area to the right. So do you recall this table? So we have the area from 2.53. From 0 to 2.53. So that is 2.553. So, nakikita nyo ba? 2.53. 2.53. So that is 0.4943. 0.4943. Ito. So, sulat natin dito. So, the area from 0 to 2.53 is 0.4943. But that is not the area that we need. We need the area from 2.53 to its right. So how do we get that one? We subtract this area from 0.5. So you will have 7, 9 minus 4, 5, 9 minus 9, 0, 4 minus 4, 0. Oh, miss, is it the same with our p-value? No. Since we have a two-tailed test, then we have to multiply this by 2. If you try multiplying this by 2, then you will get the same value. So that is how we obtain p-value, if you would like to do it manually. But why do you have to do it if it has already been generated by the PH stat? So that's the amazing part of statistics. You need not to do it manually, but you get to understand how we obtain p-value from critical value approach. So if we continue, we will be using the p-value method for hypothesis testing. So again, we use the popular levels of significance 0.05 and 0.01. So recall that we already had this in our introduction of hypothesis testing. It's the probability of getting a sample statistic or a more extreme sample statistic in the direction of the alternative hypothesis when the null hypothesis is true. So this is the actual area under the standard normal distribution curve of the test value or a more extreme value further in the tail. So the area towards the tail. So it's within the rejection region. So we reject the null hypothesis. So I would like you to recall the steps in the p-value approach in testing the significance of difference between means. So for the first step, you formulate again HO and HA. So this one is going to be faster than what we had a while ago, because this is just a recap of the critical value, but we have some twists. So using the same problem, our HO and HA will be the same. For step 2, our alpha is also 0.05. We have a two-tailed test, and you just have to copy our p-value. Ayan, that we had a while ago. So for step 3, you reject HO if the p-value is less than or equal to alpha. So this is generic, and you always use this in any of your hypothesis testing. So you reject HO whenever you get a p-value is less than or equal to alpha that you have set. or selected. So the decision rule this time is shorter, a lot shorter than the decision rule we had in critical value approach. And then for step 4, ayan, reject HO because the p-value is it must be less than, only less than alpha is 0.05. Because 0.01 is really less than 0.05. And then, for the fifth step, you have to make conclusion. So, since you reject HO, then what then is true? HA. There is a significant difference between the hypothesis and the sample means, which is the same conclusion we had in our critical value approach. So, if you intend to interpret this in the context of the problem, then there is a significant difference between the average course in the entrance exam in mathematics of this year and the previous year's examinees of big time university. Ayan. So, after discussing this, of course, I will ask you to work on something. So, that is, I hope you can work on worksheet 7B. Worksheet 7B. I hope that this video helps you understand the basics of hypothesis testing. I would be very glad to know your comments and suggestions or questions if you have any about this video, so that I can improve on this presentation or improve this presentation more. Thank you for listening. You wait for further instructions and announcements over Big Sky. Thank you. Take care, everyone. Bye.